Hello, I'm Naveen Kumar. So I've developed this EV charging management system project. So I'll quickly demonstrate how this works and how did I implement. So this actually follows OCPP 1.6 protocol. So if you know what it is, it's actually a EV management system. So when vehicle gets to charging station, and this charging station interacts with a central management system. So this I've developed this project for this central management system only. So they follow OCPP protocol. I will not go into much details of their interactions, but I will demonstrate the central management system. Let's see if let's start the server. Um, okay. At the end, I will also show the low-level designing also. Okay, so the server is running. Let's start. I'll leave the GitHub link in the description. You can then use these payloads, uh, and you can go through how to install those things also. Okay. Now let's connect. So first I will connect one charger to the server using WebSocket, and we also integrated with the REST API also, but I'll show that. So in WebSocket I'm actually connecting STS002. Okay, now we are connected, it's fine. And let's boot this. Let's send a boot notification. That means we are okay, the charger is live now. Fine. Now let's get okay, now we can see that STS002 is available. Okay, now if you see, we will connect one more charger. This is the second charger. Oh, sorry, I was sending a heartbeat. What? Okay, okay. It's saying that this charger doesn't exist because we didn't even register it yet. Okay, so now the notification is sent and we get the accepted response. So now both of our chargers are now connected to the central management system. Now every minute, every 30 seconds, or however the configuration is done, we have to the charger will send a heartbeat to the charging station, because it's just for the health management. So now let's send one heartbeat for the STS001. Okay, we will keep the STS002 as inactive for now. We will not do anything much, but for STS001 I have sent a heartbeat. Okay, now what if the charge we got an EV vehicle and we are charging it, and we are starting a new transaction. Let's start a transaction. We did the heartbeat, and now we will do the start transaction. Start transaction. I am giving some date, some outdated date, but that's fine, it will do the job for now. Charger ID is proper, and some message ID, and the amount energy consumed is currently 0. Okay, okay, that is accepted, and we got a transaction ID back. So we can use it to stop the transaction or for further processing. Let's stop the transaction. Let's close the transaction. The charging is done. Okay, but we have to update the transaction ID. Okay, we updated the transaction ID. If we send, okay, the transaction is stopped, it's accepted. Let's see, we have one more REST API. One REST API is for the stations. You can see STS001. It is currently in finishing because we updated the finishing one, but let's update the heartbeat, and it will be back to available. If you send a heartbeat, it is accepted, and now if you get it, it's available, right? STS002 is still there, it's still available. Okay, now we have another REST endpoint for transactions. If we get a transactions, we have one transaction that is just completed. 020 is the transaction ID. Is it correct? 020. Yeah, okay. So that is the transaction that is happening. So this is how we implement this. But Okay, and a part of this charger management system will also have a scheduler. So it will have a timed task for every certain period. It will do a survey. It will check what if it checks if there is any charger is not responding to us, if it is not send its heartbeat, or if it's not interacting from past some time, then it will mark it as unavailable. So this scheduler I've kept as 2 minutes here. Yeah, there is a cron job for 2 minutes. Cutoff time is 2 minutes. So every 2 minutes it will check. I'm actually okay. Now it worked. We can see that STS 002 is now marked as unavailable. I didn't do anything. I just created this in the beginning, and there was no interaction, and it automatically went to unavailable. So how it is doing is and how the entire implementation is done, I will quickly show in my component diagram. Not the component diagram, but yeah, this one. So we are following on factory design pattern. So action handler factory is acting as a factory class. It will send the action handler, the required action handler. So charger socket handler is actually taking the text messages, or taking the connections from the WebSocket, and then depending on the action that we want. So here if you see, the action is heartbeat, so then it will ask so then it will ask action handler factory to give a service class that deals with action heartbeat. So then we have a boot handler, boot notification handler, heartbeat handler, status notification handler, start transaction handler, stop transaction handler. So these are all the action handlers. They all implement action handling. And start transaction and stop transaction, they specially extend transaction handler also. So they implement action handler, and they extend transaction handler. Sorry, they implement action handler and they extend transaction handler. So because they have some common methods that they deal with. And coming to the exceptions, for WebSocket we have a different exception handling, and for REST APIs we have a different exception handling. So, and we have controller for stations and transactions. We are using MongoDB for this. We have one for we have some document for charging station, and one document for transaction repository. And there is cache memory also. So this cache memory is in memory cache memory for now. So we can integrate it with Redis if you want, but currently I'm just using some concurrent hash map. But yeah, so why we need this is for the scheduler. So scheduler runs every 2 minutes or 5 minutes. So if you have like a huge number of data available in our MongoDB, then running queries on for 2 minutes is actually too much. It will become very expensive. So I created a in-memory cache management cache memory for that, and so it will only take the the only the charging IDs and the last updated transaction time, so that we can run query on these, and we can find the ones that are not responded, not interacted in past few minutes. So yeah, I will link the GitHub link in description. So if you have any queries, you can comment down. Thank you.